Hello, dear students. Welcome back. So, this is lecture number 3 of gravitation. So, today's topic is acceleration due to gravity. Okay, first of all, we'll study the basics of the acceleration due to gravity. Then, we'll be doing the questions on this. And then, another topic is variation of acceleration due to gravity. Okay, so let's get started. The point number first is that what actually is this acceleration due to gravity? It is simply the acceleration of a particle due to the gravitational force. Okay, for example, we have a particle, like suppose we have an apple. It falls down towards the surface of earth. Why it falls down? The reason is gravitational force, and the acceleration of this apple due to the gravitational force is what we call as acceleration due to gravity. Okay, first and foremost, what we'll try to do is that we will try to derive an equation for the acceleration due to gravity. Let's try to do that. Okay, so let's assume that this is the surface of earth. Let's assume that this is the earth. All right, now this is the radius of the earth, which is capital R. This is the center of the earth, and this is radius, which is capital R. On the surface of this earth, there is a particle, a small particle whose mass is equal to small m. Okay, all right, now there will be a force on this particle, and that force is called as gravitational force. Let me write down the equation for the gravitational force. Gravitational force is given by Newton's law of gravitation, which is G capital M, which is the mass of the earth, into small m, which is the mass of the particle, divided by R square, divided by capital R square. All right, where capital R is the distance between the particle and the center of the earth. All right, okay, now this force will be in turn equal to mass into acceleration, which we famously called as Newton's second law. Then what I can write down is this also, m into g. Now what is this g? This g is simply acceleration due to the gravitational force, hence called as acceleration due to gravity. So the equation we have here is this m and this m is going to cancel. This m and m will cancel. We are left with acceleration due to gravity. So acceleration due to gravity becomes equal to gm divided by r square. All right, this is the equation for us, which we famously call as acceleration due to gravity on the surface of earth. Okay, what is the value of the acceleration due to gravity on the surface of earth? Its value comes out to be exactly 9.8 meter per second square, and for mathematical convenience we can take its value 10 meter per second square. All right, so these are some special values of acceleration due to gravity on the surface of earth, which is 9.8 meter per second square, or approximately we can take its value 10 meter per second square. लेकिन यहाँ पे एक चीज़ का आपको ध्यान रखना है, that is this acceleration due to gravity is not a universal constant. Its value changes with height, with depth, and its value will be different on the different planets or on the different stars. Okay, next, which is important for us, is this equation. Let me write down here this equation. This is g into m is equal to gr square. Since this equation is applied every now and then, that is why I have written this equation, a very important equation, gm equal to gr square. Okay, ठीक है. Important और एक point है, that is acceleration due to gravity g in terms of density of earth. In terms of density of earth, and when I say earth, I mean every single planet. Okay, acceleration due to gravity मुझे लिखना है बेटा in terms of density of the planet. How I can do that? Simply I will first of all define density. तो density is denoted by rho. किसके बराबर होती है density? Density is defined as mass per unit volume, which implies that the mass of an object is equal to density of the object into the volume of the object. Okay, what is this m? It is the mass of the earth, and rho is density of earth, and this v is the volume of the earth. Okay, now we can assume that the earth is a perfect sphere, though it is not. but the radial the difference of the radius between the equator and the poles is very small, so we can safely assume that the earth is a sphere. And you should know, आपको पता होना चाहिए वॉल्यूम ऑफ अर्थ क्या होता है, that is 4/3 pi into r cube. Okay, so this gives us mass of the earth in terms of density. Now we can easily put this equation in the equation number first, which is this one. This is our equation number first. We can easily do one thing, that is put this equation in the equation number first. We'll have one more equation for the acceleration due to gravity. That's something like this: g equals to g divided by r square. ठीक है, एंड मास विल बी रिप्लेस्ड बाय दिस, मास को हम रिप्लेस करेंगे रो इंटू 4/3 पाई आर क्यूब. ओके, नाउ वी हैव दिस इक्वेशन, g is equal to this r square and this r square is going to cancel, so we are left with this equation 4 divided by 3 into pi into g. तो पहले मैंने कॉन्स्टेंट्स लिखे, मल्टीप्लाइड बाय रो into r. So this is one more important equation for acceleration due to gravity. Again, an important equation. Let me label this equation as equation number second. ठीक है जी. So there are two equations for acceleration due to gravity. Let's do one thing. Let's summarize both these equations. So here I am going to write it. Let me summarize both these equations for acceleration due to gravity. Equation number first for acceleration due to gravity is like this. That's like this. यहाँ मैं लिखूंगा, that is g equals to gm divided by r square, which implies that acceleration is proportional to m by r square. Or it means that if the mass of the planet is taken constant, then acceleration due to gravity is inversely proportional to square of the radii of the planets. And second equation is g is equal to 4/3 pi into g multiplied by rho into r. Okay, which implies that acceleration due to gravity is proportional to rho multiplied by r. Okay, so we have two equations for the acceleration due to gravity. One is gm by r square and second is in terms of density, and both the equations are equally important. And let me write an important point here, and that is the value of this g, acceleration due to gravity, value of g does not depend on, it does not depend on a mass of object, and b is it does not depend upon the density of the object, okay. So what does that mean? That means चाहे हमें ऑब्जेक्ट हो जिसका मास कम हो या चाहे मास ज़्यादा हो, whether its mass is less or whether its mass is more, acceleration due to gravity for both the particles will be same. ठीक है. अब आपको confusion ये हो सकता है that a stone it falls down with greater acceleration and a feather falls down with a lesser acceleration. The reason is not that acceleration due to gravity depends upon the mass of the particle. The reason is that there is air resistance. ठीक है. But if we drop a feather and a stone in vacuum, the acceleration due to gravity for both the particles will be absolutely same, which means that acceleration due to gravity does not depend upon the mass of the object. So both these are important terms: does not depend upon the mass of the object and does not depend upon the density of the object. All right, so these are two key points. ठीक है, तो हमने लिखी है इक्वेशन. ठीक है, so there are two equations for acceleration due to gravity. One is this one, acceleration due to gravity is equal to gm by r square, and second is this equation, acceleration due to gravity in terms of density of the planet. Okay, so I am sure that these two equations are absolutely clear to you. Let's try an example here. Let's do a question here. Okay, तो क्वेश्चन कुछ इस तरह से हैं. Example is like this. Example number 1, that's like this. There are two planets. Okay, concentrate here. This is planet A. The radius of this planet is equal to, that is r. And this another planet, which is planet B. The radius of this planet is twice r. All right, so these are two planets, planet A and planet B. The radii of the two planets given r and 2r. All right, and what we are supposed to calculate is this: calculate acceleration due to gravity on planet A is to acceleration due to gravity on planet B. That means we have to calculate the ratio of the acceleration due to gravity on the surface of the two planets. Condition is given if A, B. A is that their masses are same. If mass of A is equal to mass of B. Number second is that there are two planets whose density is same. That means density of A is equal to density of B. And what we are supposed to calculate, we have to calculate the ratio of the acceleration due to gravity. Now you know that there are two equations for the acceleration due to gravity. So A part के लिए हम ये वाली equation use करेंगे that acceleration due to gravity is proportional to m by r square. Now when m is constant, this implies that this acceleration due to gravity is inversely proportional to square of the distance, because it is given that the mass of the two planets is exactly same. Now what does that mean? That means GA divided by GB is equal to RB divided by RA, inversely proportional, whole square. Is that clear? Now you tell me what is the radius of the planet B, that is twice r, and what is the radius of the planet A, that is r. So let's write down here, this is 2r divided by r whole square. R and r is going to cancel. 2 square comes out to be 4 divided by 1, which means that acceleration due to gravity on planet A is to acceleration due to gravity on planet B is 4:1. Okay, so this is the answer to this question, and I'm sure that this is clear to you. Okay, now B part is that in the B part it is mentioned that the density of the two planets is same. If the density is mentioned in the question, that means I will have to write down the acceleration due to gravity in terms of density and radius. And what's the equation? That is rho multiplied by r, isn't it? Okay, now from here what I can write down is that the acceleration due to gravity is directly proportional r, because it is mentioned in the part B that the density of the two planets is exactly same. All right, this means that this in turn means that acceleration due to gravity on planet A is to acceleration due to gravity on planet B will be equal to a radius of planet A is to radius of planet B. And what's the radius of A? That is r, and radius of B is twice r. So r and r is going to cancel. So this will be 1:2, which implies that acceleration due to gravity on planet A is to acceleration due to gravity on planet B will be equal to 1:2. So what is the ratio of the acceleration due to gravity on the surface of the two planets? It will depend upon which physical quantity is constant. Is mass constant or is density constant? Then accordingly we will have to write down the equation, and then accordingly we can see what is the ratio of acceleration due to gravity on the surface of the two planets. Okay, let's switch to another subtopic here, another subtopic, and that subtopic is variation of acceleration due to gravity. Okay, variation of acceleration due to gravity. Wait a moment, let's do some PYQs first before switching this another subtopic. हम यहाँ पे कुछ questions कर लेते हैं. After that we'll be doing one thing, and that is variation of acceleration due to gravity. Okay, so let's try to do these examples first and foremost. So this is example, and this question has been asked in JEE Man 2025. Let's try to crack this question. So what is given in the question is that the acceleration due to gravity on the surface of Earth is g. That is given to you. If the diameter of the Earth is reduced to 1/3 of its original value, 1/3 of its original value, and important thing is that mass remains unchanged, then the acceleration due to gravity on the surface of Earth is, you will have to calculate what is the new value of acceleration due to gravity on the surface of Earth. Okay, अगर आप क्वेश्चन अच्छे से देखोगे, there are two things which are mentioned in the question, that is number one radius and number second mass, which means that we will have to write down the acceleration due to gravity in terms of mass and radius. So that is this equation, that is g is proportional to m divided by r square, isn't it? Now it is given in the question that the mass remains unchanged. Now what does that mean? That means acceleration due to gravity is inversely proportional to square of the radius. Okay, that implies that we have to calculate the new acceleration due to gravity. I will write it like this: g2 divided by g1 is equal to r1 divided by r2 whole square, simply because it is inversely proportional. Now tell me one thing, what is the initial radius of the earth? Let's suppose that is r. What is the new radius of the earth? It is given that it is mentioned in the question that the diameter of earth is reduced to 1/3 of its original value. जब हमने diameter को reduce किया 1/3, so that means radius will be also reduced to 1/3, which means that the new radius will be equal to r divided by 3 whole square. ठीक है जी? This r and this r will cancel. This 3 square is 9, so it comes out to be simply 9. तो इसका मतलब है acceleration due to gravity, new acceleration due to gravity will be 9 times the initial acceleration due to gravity, which is g. So this is the answer to this question, that g2 is equal to 9 times g. क्या हमारे पास ऐसा कोई ऑप्शन है? हाँ है, that is option number A. So this is the answer to this question. So quite easily done. Let's switch to another question. देख ले बेटा, ये और एक क्वेश्चन है. This question has been asked in JEE Man 2023 and let's try to do this question also. तो क्वेश्चन में क्या दिया गया है? Two planets, there are two planets A and B. Radii of the two planets given r and 1.5 r. There the density is rho and rho by 2. So that means the density is mentioned and the radius is mentioned. So that means we'll have to write down the acceleration due to gravity in terms of density and radius. All right. The ratio of acceleration due to gravity at the surface of B is to A is. Have a look. What is given is that the radius of the planet A is given, that is r. The radius of the planet B is given to you, that is 1.5 r. Great, perfect. Density of the planet A is given, that is equal to rho. Density of the planet B is given, that is equal to rho divided by 2. Okay. Now we will have to calculate acceleration due to gravity, that is GB is to GA. This is what we are supposed to calculate. Okay. So easily we can do it. The first thing you will do is that we'll write down the acceleration due to gravity in terms of rho and r. I know that acceleration due to gravity is directly proportional rho multiplied by r. Okay, already we have discussed this in detail. That means acceleration due to gravity on planet B divided by acceleration due to gravity on planet A will be equal to something like this. It is density of planet B divided by density of planet A into radius of planet B divided by radius of planet A. Now let's try to substitute the values here. What is density of B? That is rho by 2. So I am writing here rho by 2. What is the density of planet A? That is rho, given to you in the question. Radius of B is equal to 1.5 r and radius of planet A is r. Now have a look. This rho and rho will cancel and this r and r is also going to cancel. Okay, then here we have, this is 1 by 2 into 1.5 can be easily written as 3 divided by 2. 3 divided by 2. Now 3 into 1 is 3, 2 into 2 is 4. So ये आएगा 3 divided by 4. So which implies that acceleration due to gravity on planet B is to acceleration due to gravity on planet A is equal to 3 is to 4. So this is the answer to this question. Okay, which means that इसका जो answer है that is part C. Perfect. Let's switch to another question. देख ले बेटा, और एक क्वेश्चन ये दिया गया है. तो नेक्स्ट क्वेश्चन जो है वो ये है कि if the radius of the earth shrinks by 2% while its mass remains same, that means the mass remains constant, 2% and mass remains same. This is important. Acceleration due to gravity on earth. What will happen the acceleration due to gravity on the earth? Then different options are given to us. This question has been asked in JEE Man 2022 and it's a very easy question. Easily within no time, even orally we can do this question. देख ले बेटा, acceleration due to gravity I will have to write it in terms of mass and radius. That means G is proportional to m by r square. Can I write like this? Can I write like this? This acceleration due to gravity is inversely proportional to square of the distance, square of the radius. Because it's mentioned in the question that acceleration due to gravity, that the mass of the planet that remains same. Okay. Now अब देख ले बेटा, क्वेश्चन में ये दिया गया है that the radius of the earth shrinks by 2%. That means r decreases by 2%, which implies it's a small percentage. It's a small percentage. So first and foremost, you tell me one thing: what will happen to acceleration due to gravity? Will that increase or will that decrease? Obviously it will increase. Why? Because acceleration due to gravity is inversely proportional to square of the radius. Okay, so that means acceleration due to gravity increases. Tell me one thing: what is the power of this r? That is 2. So simply acceleration due to gravity will increase by 2, the power of this r, into 2%. 2 into 2 is 4%. But this is applicable only for small percentages, which means that acceleration due to gravity increases by 4%. So this is the answer to this question. Okay, so it increases, acceleration due to gravity increases by 4%. So this is the answer to this question. All right. Okay, let's switch to another question. देख ले बेटा, और एक क्वेश्चन यहाँ पे ये है. This question has been asked in JEE Man 2023, and the question is like this: the radii of two planets A and B are R and 4R. So that means the radii of the two planets are given to you. All right, that is given to you, R and 4R. Their density is also given, rho and rho by 3. The ratio of the acceleration due to gravity, that means GA is to GB, we have to calculate. I can easily write down the equation that is G in terms of density and R is something like this. G is directly proportional to rho multiplied by R. Okay, which means that GA divided by GB will be equal to rho A by rho B multiplied by RA divided by RB. ठीक है? Okay, so what is the density of the planet A? That is rho. What is the density of the planet B? That is rho divided by 3. What about radii? Radius of the first planet is given, that's R, and the radius of the second planet is given, that is 4R. Rho and rho, R and R are going to disappear. तो यहाँ पे जो यहाँ पे है डिनोमिनेटर में 1/3, so it will become 3 divided by 4. So the answer is simply, it is what it is, 3 is to 4. So this is the answer to this question. I hope that this question is also absolutely clear to you. Let's try to do this question. तो ये question है क्या, that a planet has double the mass of the earth. So there are two planets. Okay, double the mass of the earth. It is given that the mass of the planet is 2 times the mass of the earth. All right, its average density is equal to that of the earth. It is given that the density of the planet is equal to density of the earth. An object weighing W on the earth will weigh on that planet. What will be the weight of the object on that planet if it weighs W on the surface of earth? Okay, one thing that's very important is that whatever will happen to the acceleration due to gravity will happen to the weight, because you know that this weight is equal to mass into acceleration due to gravity. Okay, isn't it? Now the first thing I have to write down is that the acceleration due to gravity in terms of mass and density, or how it depends upon the mass and density of a planet. All right, I have written down the equation that G is directly proportional to m by r square and is directly proportional to density multiplied by r. But I have to write down the equation acceleration due to gravity in terms of mass and density. Okay, in terms of mass and density. Tell me one thing. What is this density equal to? It is mass by volume, isn't it? Okay, now can I write down like this, that this density is proportional to m divided by this V is in turn proportional to r cube, isn't it? Is this clear to you? Okay, is this clear to you? Now from this equation I can write down like this, that this r cube is proportional to m divided by rho. Okay, m divided by rho. M divided by rho. Is that absolutely clear to you? Which in turn implies that this r is proportional to m by rho raised to the power 1 by 3. Raised to the power 1 by 3. I hope that this is also clear to you. So what about this r square? This r square is proportional to m by rho raised to the power 2 by 3. Squaring both sides. So yeah, now I will do one thing, that is put this r square in this very equation, that g is proportional to m by r square. The r will disappear. The equation will be in terms of mass and density, which I actually want. So that means what I am going to write down here is this. What I am going to write down here is this, that is acceleration due to gravity. That is acceleration due to gravity. Let me write it down here. That is acceleration due to gravity is proportional to m by r square. Hence it is proportional to m divided by r square is proportional to m by rho raised to the power 2 by 3. Clear? Which implies that this acceleration due to gravity is proportional to m raised to the power 1 minus 2 by 3. Bases are same, powers are subtracted in division into rho raised to the power 2 by 3. So eventually I can write down like this, that this acceleration due to gravity is proportional to m raised to the power 1 minus 2 by 3 is 1 by 3 into rho raised to the power 2 by 3. A very important equation. A very important equation. This one. That acceleration due to gravity depends upon mass and density also. It depends on mass and density. It depends upon mass and density. Mass and density. Now since the density is constant, so what I can write down is that the g is proportional to m raised power 1 by 3, because it's mentioned in the question that density is constant. Alright. Now we are supposed to calculate what will be the weight of the object on that planet. Let me write down it like this, that this gp, acceleration due to gravity on the planet, divided by g will be equal to mass of the planet divided by mass of earth. Let me take that as m. Okay, me whole raised power 1 by 3. Is that clear? Now have a look, my dear students. Have a look. That it is given that the mass of the planet is 2 times the mass of the earth. Mass of planet is 2 times the mass of earth. I am writing here 2 times mass of earth divided by mass of earth. This mass of earth and mass of earth will disappear. तो ये बन जाएगा बेटा equation. It will be 2 raised to the power 1 by 3, which means that acceleration due to gravity on the surface of planet will be equal to 2 raised power 1 by 3 acceleration due to gravity on the earth. Or it means that the weight of body on planet will be equal to 2 raised power 1 by 3 into w, because whatever will happen to the acceleration due to gravity will happen to the weight, simply because weight of an object is equal to mass of the object into acceleration due to gravity. मास पे तो कोई फर्क पड़ने वाला नहीं है, लेकिन acceleration due to gravity change होगा and hence the weight will change. Okay, so the answer to this question, it was a bit lengthy. The answer to this question is this one, that is 2 raised to the power 1 by 3 into w. Okay, so at the end let me write down an important equation, that is this g is proportional to m by r square. Number one equation. Number second is that it is proportional to rho into r. And number third is that, let's add this one as well, it's proportional to m to the power 1 by 3 rho to the power 2 by 3. All these three equations are very very important. लेकिन ज़्यादातर questions जो इस पे आते हैं, they are asked in the equation number first and equation number second. And there are high chances that in the NEET, this question, that the question on this, that g is proportional to m raised power 1 by 3 into rho raised power 2 by 3, there are high chance that this question will not be asked in the NEET, especially in the JEE mains that can be easily asked. Okay, now let's move to another question. So let's move to another question. The another question we have is this. ये question हमारे पास है, that acceleration due to gravity on the surface of earth is g if the diameter of earth reduces to half of its original value and the mass remains constant, then acceleration due to gravity on the surface of earth would be. Okay, we have done this type of question already. I will simply write down one thing, that is acceleration due to gravity is proportional 1 by r square, and I will keep this question as a home assignment. I am very much sure that you can easily do this question. Okay, another question, NEET 2018 question, a conceptual question. It has nothing to do with the mathematics. तो देख ले बेटा आप क्वेश्चन है क्या. It's like this. If the mass of the sun were 10 times smaller, so that means the mass of the sun is decreased, and the universal gravitational constant were 10 times larger, implies the gravitational constant. For example, it is a hypothetical situation in which the gravitational constant is increased 10 times. That means new gravitational constant becomes 10 times its initial value. Then which of the following is not correct? The important thing is that not correct. Which of the following is not correct? Option number first is that raindrops will fall fast. It is correct, because simply acceleration due to gravity is directly proportional to gravitational constant. When the gravitational constant will increase 10 times, that in turn implies acceleration due to gravity will increase 10 times, hence raindrops will fall faster. So this is correct, but we have to find which of the following is not correct. Walking on the ground will become more difficult. That's also true, because when acceleration due to gravity will increase, so it will become difficult to walk on the surface of earth. G on the earth will not change, so this is the correct option, that G will not change. G will of course change. Why G will change? Because acceleration due to gravity is equal to gm divided by r square. It is simply directly proportional to this capital G. You change the capital G, the acceleration due to gravity is going to change. And option number D जो हमारे पास है, that is time period of simple pendulum of earth will decrease. Time period of simple pendulum अगर आपको याद होगा, that is 2 pi square root of L divided by G. Now since acceleration due to gravity will increase, so the time period of the simple pendulum will decrease. That is true, but हमें देखना है which of the following is not correct. So इसका जो आंसर है, that is part C, that G will not change. Okay, so this is the correct answer. Now let's have a look at the next question. This one has been asked in NEET 2024. Let's try to do this question. What is given in the question is this: the mass of the planet is 1/10 of the mass of the earth. So again, there are two different planets. One is earth and another is some planet, and its diameter is half that of the earth. The acceleration due to gravity on the planet is on the surface of that planet is, you will have to calculate the value of acceleration due to gravity on the surface of that planet. Okay, so what I will do is that I will write down the acceleration due to gravity in terms of mass and radius. It is simply proportional to m by r square. All right. Okay, then I will write down something like this, that is gp divided by g will be equal to mass of the planet divided by mass of the earth, multiplied by what? Multiplied by, this is the radius of earth divided by radius of planet whole square. Okay, then it's given that the mass of the planet is 1 by 10 times the mass of earth. Mass of planet is 1 by 10 mass of earth divided by 10, which implies that यहाँ पे मैं simply लिखूंगा 1 by 10, isn't it? Because mass of planet divided by mass of earth will be 1 by 10 into, then it is given that the radius of planet diameter is half that of the earth. So that means radius of planet is radius of earth divided by 2. Can I write like this, that this 2 is equal to radius of earth divided by radius of planet? Let's put it here. So this is 2 square. 2 square is 4, so it comes out to be 4 divided by 10. 4 divided by 10 is in turn equal to 2 divided by 5. Okay, 2 divided by 5, which means that the acceleration due to gravity on the surface of that planet is 2 by 5 times the acceleration due to gravity on the earth, which is g. 2 divided by 5, I will write down here 9.8 meter per second square. Okay, or let's do one thing, let's write down the 10 meter per second square for mathematical convenience. 5 1 5 2, 2 into 2 is 4 meter per second square. Now let's have a look on the options. There's only one option which is close to 4 meter per second square, that is 3.92. So the correct answer to this question is 3.92 meter per second square. Okay, so next सब टॉपिक जो हमारे पास यहाँ पे है बेटा, that is the variation of acceleration due to gravity, the variation of acceleration due to gravity. तो नेक्स्ट टॉपिक जो हमारे पास यहाँ पे है, दैट्स वेरिएशन ऑफ एक्सेलरेशन ड्यू टू ग्रेविटी. ओके, सो द फर्स्ट थिंग यू शुड नो इज दैट द एक्सेलरेशन ड्यू टू ग्रेविटी इज नॉट a universal constant. This g is not a universal constant. When it's not a universal constant, what does that mean? That means its value is not constant everywhere. Number one. Number second is that its value is not same for all the planets or for all the stars. So how acceleration due to gravity varies? Number one, it varies with the height. Number second, it varies with the depth as you move away from the surface of Earth. Upwards or downwards, it varies. Number third, it varies with the distance from the center of the Earth. And number four, it also varies with the shape of the Earth. And it also varies with the rotation of the Earth. We will discuss each of these one by one. First and foremost, we will discuss how acceleration due to gravity varies with the height. The point number first जो मैं यहाँ पे लिखूँगा वो ये है कि वैल्यू ऑफ जी जो है, वैल्यू ऑफ एक्सेलरेशन ड्यू टू ग्रेविटी, वैल्यू ऑफ जी, इट डिक्रीजेज विद हाइट. दैट इज द फर्स्ट पॉइंट, डिक्रीजेज विद हाइट. ओके, अब आप बोलोगे सर इसका रीजन क्या है, व्हाई एक्सेलरेशन ड्यू टू ग्रेविटी डिक्रीज विद हाइट. द लॉजिक इज वेरी सिंपल, द लॉजिक इज वेरी सिंपल. दैट इज as you move away from the surface of Earth, the gravitational force will decrease. And when the gravitational force will decrease, so obviously acceleration due to gravity will also decrease. That's the reason. Okay, can we prove it mathematically? Yes, of course we can prove it mathematically. Let's try to do that. तो देख ले बेटा, ये आप assume कर लो this is earth, this is our green earth. All right, ठीक है जी. Okay, so we know the acceleration due to gravity on the surface of the earth, and what's that? That is g. Can we write down this g? Yes, of course we can write down this g. What is this g equal to? It is gm divided by r square. From this equation what follows is this. यहाँ से हम लिख सकते हैं gm is equal to g into r square. Let me say that this is our equation number first. Okay, now let's do one thing. Go upwards through a height of h. तो यहाँ हम पहुँचे. So this height h. So on the surface of Earth, the acceleration due to gravity is simply what? That is g. यहाँ पे जो acceleration due to gravity and that is g. And at height h, the acceleration due to gravity is gh. ठीक है जी. Now can I say like this, that the acceleration due to gravity at the height h is equal to g into m divided by, आप मुझे बताइए यहाँ से लेकर यहाँ तक की डिस्टेंस टोटल कितना है? इट इज सिंपली r प्लस एच. तो डिनोमिनेटर में क्या आ जाएगा यहाँ पे? दैट विल बी r प्लस एच होल स्क्वायर. सही है. तो इस gm के बदले में क्या लिखूंगा? व्हाट आई विल राइट डाउन हियर इज दिस इज इक्वल टू g इंटू आर स्क्वायर डिवाइडेड बाई r प्लस एच होल स्क्वायर. ये जी आर स्क्वायर कहाँ से लाया मैंने? इट इज सिंपली, इट फॉलोज फ्रॉम द इक्वेशन नंबर फर्स्ट, दैट इज gm इज इक्वल टू जी आर स्क्वायर. So we have a super important equation here, that is gh is equal to gr square divided by r plus h whole square. This equation will give you, let me write down, this is equation number a because it's a very very important equation. तो ये equation जो आपके पास है, it gives us value of g at height h. Okay, for example, the question is calculate acceleration due to gravity at a height of 6000 kilometers, 2000 kilometers, 4000 kilometers, 400 kilometers. We can simply use the equation a to calculate the value of acceleration due to gravity at height h. Okay, now here we have a special case. Let me write down here, my dear NEET and JEE aspirants, that special case is something like this. Special case जो यहाँ पे है वो ये है, if this h is very very small compared to r. ठीक है जी. फॉर एग्जाम्पल आपको कैलकुलेट करना होगा एक्सेलरेशन ड्यू टू ग्रेविटी एट हाइट 5 किलोमीटर्स. नाउ दिस 5 किलोमीटर जो है, इट इज वेरी वेरी स्मॉल कंपेयर टू रेडियस ऑफ अर्थ. एंड व्हाट्स रेडियस ऑफ अर्थ? 6,400 kilometers. This is what I mean to say, that h is very very small compared to r. Okay, in that very case we have an equation like this: gh is equal to g into 1 minus 2h divided by r. This is our another important equation, another very very important equation. And you know what, this equation has been directly asked as such in JEE Mains. You'll see that later on. ये क्वेश्चन डायरेक्टली आया है बेटा. What is the acceleration due to gravity at height h when this h is very very small compared to r? So that is gh is equal to g into 1 minus 2h divided by r. अब आप बोलोगे सर ये इक्वेशन कहाँ से लाई आपने? We have simply done one thing, that is इक्वेशन a को हमने सॉल्व किया है using what we call as binomial theorem, and then we have neglected the higher powers. On doing that we arrived at the equation number b. अब जो बीच में जो मैथमेटिक्स हैं that is not our concern, because anyway आपको ये दोनों इक्वेशंस याद रखनी है. We have derived this equation, equation number a, but you will have to. The reason is that you cannot afford to derive this in the NEET or in JEE Mains exam. So we are done with these fundamental equations, some basic equations. Let me highlight these super important equations for you. Equation number first and then the equation number second, which are deadly important. Okay, so many questions have been asked on these two equations in NEET and JEE Mains. ठीक है जी. Let's do some practice questions here. Let's do one thing, let's do some practice questions here. फिर उसके बाद हम NEET और JEE PYQs करते हैं. ठीक है ना. तो क्वेश्चन कुछ ऐसे हैं, क्वेश्चन कुछ ऐसे बेटा. क्वेश्चन ये है, एग्जाम्पल नंबर 1, कैलकुलेट वैल्यू ऑफ g, calculate value of acceleration due to gravity, acceleration due to gravity at height h. A part is that this h is given to us, it is equal to r. Then B part is that h is given, that is equal to twice r. C part is that h is given, it is equal to 3 times r. D part is that h is equal to 4 times r. E part is that h is equal to r divided by 2. F part is that h is given to you, that is r divided by 3. Okay, let's try to solve the question number, this part A. This part A, how can we do that? We can do that easily, it's not a big deal. तो सिंपली करना क्या है बेटा, हमें सबसे पहले एक इक्वेशन लिखनी है, दैट इज जी एच इज इक्वल टू जी आर स्क्वायर डिवाइडेड बाई आर प्लस एच होल स्क्वायर. ठीक है जी, ये इक्वेशन आपको याद होनी चाहिए, ओनली देन यू कैन डू दिस क्वेश्चन. ओके, नाउ व्हाट इज द वैल्यू ऑफ दिस एच? द वैल्यू ऑफ एच इज गिवन टू यू, दैट इज एच इज इक्वल टू आर. लेट्स पुट दैट इन द इक्वेशन. जी एच इक्वल्स टू जी इंटू आर स्क्वायर डिवाइडेड बाई एच के बदले हम यहाँ पे आर पुट करेंगे, तो ये आ जाएगा बेटा आर प्लस आर होल स्क्वायर. ठीक है जी. सो आर प्लस आर इज ऑब्वियसली इक्वल टू ट्वाइस आर, and what will be this twice r whole square? It will be gr square divided by 2 square is 4 into r square. R square and r square is going to cancel. We are left with this answer, that is acceleration due to gravity at a height of h which is equal to radius of earth becomes g divided by 4. अब आपके जहन में क्वेश्चन होना चाहिए, सर क्या कोई डायरेक्ट मेथड है? इज देयर एनी शॉर्टकट मेथड which is even better than this, which can save a lot of time? Yes, of course there is. There's a trick. Okay, a special trick, that is something like this. एक तो मैंने आपको प्रॉपर फिजिक्स यूज करके एक क्वेश्चन दिखाया. नाउ वी कैन डू दिस क्वेश्चन orally. वो कैसे कर सकते हैं? सिंपली आई विल राइट डाउन हियर इफ दिस h is equal to n times r, where n is the coefficient of this r. then in that very case my dear students, gh जो हैं that will be equal to g divided by n plus 1 whole square. A very important equation, g divided by n plus 1 whole square. यहाँ पे जो ये n है, it is simply what it is the coefficient of r. Now have a look my dear students, there is part A. इस part A में क्या दिया गया है? h किसके बराबर है? तो आप मुझे बताइए वहाँ पे n का वैल्यू है क्या? दैट इज सिंपली 1. तो अगर आप इस पार्ट इसमें आप लगाओगे पुट n इक्वल टू 1, तो बताइए मुझे 1 + 1 इज इक्वल टू व्हाट, दैट इज 2, 2 square is 4, so that means easily with no time we have calculated acceleration due to gravity which comes out to be g divided by 4. अब देख लें बेटा एक साइड से कितना मैथमेटिक्स हमने यूज़ किया और दूसरी साइड से स्पेशल ट्रिक हमने यूज़ की, एंड विद नो टाइम वी हैव गॉट द आंसर. सी दैट बी पार्ट इज देयर. बी पार्ट है क्या बेटा, दैट इज h इज इक्वल टू 2r. नाउ टेल मी वन थिंग, व्हाट इज द वैल्यू ऑफ n देयर? सर दैट इज 2. सो लेट्स पुट द वैल्यू ऑफ n इक्वल टू 2. लेट्स पुट द वैल्यू ऑफ n इक्वल टू 2. तो जी एच जो आएगा बेटा दैट विल बी g डिवाइडेड बाई n के बदले हम यहाँ पे 2 लिखेंगे. 2 + 1 कम्स आउट टू बी 3, तो ये आ जाएगा बेटा 3 स्क्वायर, एंड 3 स्क्वायर इज सिंपली 9. तो आंसर आ जाएगा बेटा विद नो टाइम दैट इज g डिवाइड बाई 9. इवन वी कैन डू दिस क्वेश्चन ऑरली. देख लें बेटा आप यहाँ पे देख लें बेटा आप यहाँ पे आप मुझे बताइए n क्या है, दैट इज 3. टेल मी वन थिंग, व्हाट इज दिस 3 + 1? सर दैट इज 4. ओके 4 स्क्वायर इज व्हाट, दैट इज 16. तो आंसर आ जाएगा डायरेक्टली विदाउट यूजिंग योर पेन एंड पेपर. द आंसर इज g डिवाइडेड बाई 16. अच्छा मुझे बताइए इसमें इस डी पार्ट में आंसर क्या आ जाएगा, व्हाट्स द वैल्यू ऑफ n? सर वहाँ पे तो n 4 है. 4 + 1 इज इक्वल टू व्हाट, 5. 5 स्क्वायर इज 25. द आंसर विल बी directly g divided by 25. Now let me do one thing, let me show this e part to you. F will stay as a home assignment for you. Okay, so this part C, part D is home assignment for you. This is home assignment, this also home assignment, and I've shown you how to do this question with no time, orally without using pen and paper. तो यहाँ पे जब आप लिखेंगे बेटा n, क्या आप n लिखोगे यहाँ पे इन दिस पार्ट, इन द पार्ट ई, क्या आप यहाँ पे n लिखोगे 2 कि 1/2? सी दैट दिस 2 इज नॉट द कोफिशिएंट ऑफ r, 1/2 इज द कोफिशिएंट ऑफ r. तो यहाँ पे n का वैल्यू क्या आप पुट करोगे, n इज इक्वल टू व्हाट, दैट इज 1 डिवाइडेड बाई 2. नाउ gh विल बी इक्वल टू g डिवाइडेड बाई n + 1 विच इज 1/2 + 1 होल स्क्वायर. ठीक है जी. तो बताइए मुझे 1/2 + 1 किसके बराबर होता है? 2 × 1 इज 2, 2 + 1 इज 3, तो ये आ जाएगा बेटा 3/2 होल स्क्वायर. ठीक है जी. ओके टेल मी वन थिंग, व्हाट इज 3 स्क्वायर इक्वल टू, दैट इज 9. व्हाट इज 2 स्क्वायर इक्वल टू, दैट इज 4. तो ये आ जाएगा बेटा 4g डिवाइडेड बाई 9. सो दिस विल बी द आंसर टू दिस क्वेश्चन. ओके, I hope that this question is absolutely clear to you. And though this question seems easy to you, but it is very important. Calculate the value of acceleration due to gravity at height h equal to r or 2r or 3r or whatever it is. तो डायरेक्ट जो इसका मेथड है बेटा वो ये वाला है. दिस इज द डायरेक्ट फॉर्मूला टू सॉल्व दिस क्वेश्चन. A very important question. That's why I have highlighted this equation for you. ओके ऑल राइट. ठीक है जी. और एक चीज़ आप याद रखेंगे, और एक चीज़ आप याद रखेंगे, यहाँ मैं लिखूँगा इफ दिस h इज इक्वल टू n टाइम्स r, दिस gh विल बी इक्वल टू g डिवाइडेड बाई n + 1 होल स्क्वायर. एंड वट एवर विल हैपन टू एक्सेलरेशन ड्यू टू ग्रेविटी विल हैपन टू वेट, because weight is equal to mass into acceleration due to gravity. Mass is not going to change, but if the acceleration due to gravity changes, the weight also changes exactly in the same way, exactly by the equal amount. So this is our important equation. तो ये equation मैंने ऐसे यहाँ पे लिख के रखी है बेटा. So this equation is going to help you a lot. all right people. तो हमने यहाँ पे किया है वेरिएशन ऑफ एक्सेलरेशन ड्यू टू ग्रेविटी with height. Let us discuss another factor, and that is the depth. How acceleration due to gravity varies with the depth. ठीक है जी. How acceleration due to gravity varies with the depth. तो देख ले बेटा. So next I am going to write down here is this, that second factor on which the acceleration due to gravity depends is the depth from the surface of earth. तो यहाँ पे मैंने लिखा with depth. ओके द फर्स्ट थिंग जो आपको पता होना चाहिए, what happens to acceleration due to gravity with the depth? So you will just use your logic. आप बोलोगे सर चूंकि हम जा रहे हैं towards the center of the earth, distance कम हो रहा है, acceleration due to gravity will increase. It is absolutely wrong. So the first point I will write down is that the value of g, it does not increase with the depth. Value of g decreases with depth. What does that mean? That means as you move from the surface of earth to the center of the earth, the value of g decreases and finally becomes zero. Eventually it becomes zero at the center of earth, which is very, very important. At the center of the earth. So that means at the center of earth there is acceleration due to gravity is zero, and hence there is weightlessness at the center of the earth. आप याद रखेंगे बेटा ये, ठीक है जी. Okay, we'll discuss this in detail कि how acceleration due to gravity actually decreases as you move from the surface of earth to the center of the earth. Okay, so have a look. Try to understand this concept, this very important concept. तो ध्यान रखिए बेटा. This for example our earth, our beautiful earth. तो ये है बेटा इस earth का radius. This is the radius of that earth. This is the center of the earth and this is the radius of the earth. All right. Now suppose that, imagine that you are sitting on the surface of earth. When you are sitting on the surface of earth, you are attracted by the whole earth, by the entire mass of the earth, which is capital M. Is that clear? Let that idea sink in. अगर आप surface of earth पे हो तो आप पे जो gravitational force पड़ेगा, that will be because of the entire earth. Okay, now let's assume one thing. एक thought experiment है बेटा. Dig a tunnel from the surface of earth to the center of the earth and go deeper into the tunnel. अब आप मान लो बेटा आप यहाँ पे हो, यहाँ इस पॉइंट पे, आप यहाँ इस पॉइंट पे हो, ठीक है जी. Now you are here at this very point. Are you attracted? Now the question arises. What I am trying to say you is that how the acceleration due to gravity decreases as you move from the surface of earth to the center of earth. तो जब आप यहाँ पे हो इस पॉइंट पे, the question is, are you attracted by the whole earth or not? The answer is no, you are not attracted by the whole earth. You are attracted by only this portion of the earth, that means this mass. Now tell me one thing, my dear students. Is this dashed portion mass less than, for example, it's M dash. Is this M dash less than this capital M or greater than this capital M? Obviously, it is less than this capital M, which implies that when you are at the point, for example, this is point A, this is point B. When you are at point A, you are attracted by capital M. And when you are at point B, you are attracted by M dash, which is less than capital M. Okay, this is what you call as Newton's shell theorem. Newton's shell theorem tells me that the acceleration due to gravity or the gravitational force at point B is not due to this dotted shell. It is not due to the skin of this earth. It is because of this pulp, because of this core of the earth. Okay, so as you move deeper and deeper towards the center of earth, this M dash is going to decrease and hence acceleration due to gravity decreases. I hope that this is crystal clear to you. I can give you one more example. That's like this. Geography में आपने पढ़ा होगा क्लास 10th और 9th whatever it is, आपने एक कॉन्सेप्ट एक पढ़ा होगा that the earth has 3 different layers. One we call as crust, एक को हम crust कहते हैं, ठीक है जी. Another we call as mantle, and the final one is called as the core, isn't it? Okay, so this region is called as crust and this one is called as mantle and this region is called as the core, isn't it? Now let me label here 3 points: point A, point B and point C. According to Newton's Shell theorem, it says to me that if you are at the point A, then the gravitational force on you, or the acceleration due to gravity, will be because of crust, mantle, as well as core. And if you are at the point B, then the gravitational force on you will be only because of core and mantle, not because of the crust. So that means at the point B the gravitational force will be less. और अगर आप यहाँ पॉइंट सी पे हो, तब आप पे जो फोर्स पड़ेगा दैट विल बी ओनली ड्यू टू द कोर, नॉट ड्यू टू मेंटल, नॉट ड्यू टू द क्रस्ट. That is Newton's Shell theorem for you. Okay, beta. Now, is there any mathematical proof that acceleration due to gravity decreases with the depth? Yes, of course, there is a mathematical proof. Let's have a look at that. तो यहाँ पे ध्यान रखेंगे आप बेटा. तो मैं एक काम करने जा रहा हूँ. Let me redraw this diagram. This is assumed to be Earth. This is the center of Earth, so this is the radius of the Earth, isn't it? This is center of Earth. Let me label it as point O. This is the center of Earth. ठीक है जी. तो यहाँ पे आप एक point मान लीजिए, which is at a depth of d from the surface of Earth. So obviously this distance will be r minus d, because the radius of the Earth is r. So this distance has to be r minus d. What is the value of acceleration due to gravity on the surface of Earth? That is g. What is the value of acceleration due to gravity at this very point? That is gd. Gd implies acceleration due to gravity. Acceleration due to gravity at depth d. Now I am saying that the acceleration due to gravity at the depth d will be only because of this red circle, this one, only because of this. ठीक है जी. ओके ओके ओके. तो आप मुझे बताइए सबसे पहले हमारे पास कितनी इक्वेशन है. हाउ मेनी इक्वेशंस वी हैव for the acceleration due to gravity? There are primarily two equations. Let me write down the acceleration due to gravity in terms of density. Is that like this? 4 divided by 3 pi into g multiplied by rho into r, isn't it? Now since the density of this dashed portion, density of this portion and the total density nearly remain the same. So that means when the density is constant, I can easily write down this g is directly proportional to r. G is directly proportional to r. Okay, that means I can write down this equation quite easily, that is gd divided by g is equal to r minus d divided by r, isn't it? Because simply from here to here the radius is r, and from here to here the distance is r minus d. Okay. Now obviously r divided by r is 1 minus d by r. I can also write it like this. So finally the acceleration due to gravity at depth d becomes equal to something like this: 1 minus d by r multiplied by g. This is a very, very important equation, highly important equation. Highly important equation. This is acceleration due to gravity at depth d, which is 1 minus d by r multiplied by g. Again see that the acceleration due to gravity with depth d gd, it is less than the acceleration due to gravity g. Okay, you see that अगर आप इस इक्वेशन पे फोकस करोगे, this one numerator is less than the denominator, which in turn implies that this gd is less than g. Okay, so that means the acceleration due to gravity is maximum at the surface of Earth, and as you move from the surface of Earth to the center of Earth, acceleration due to gravity will decrease. तो important point यहाँ पे मैं लिखने जा रहा हूँ, plot gd versus d graph. So tell me one thing, my dear students. What is the value of acceleration due to gravity on the center of Earth? Sir, that is 0. How? Because you can easily put at the center of Earth this d is equal to r. If this d is equal to r, this here 1 minus 1 is 0. Hence acceleration due to gravity at the center of Earth is 0. What about acceleration due to gravity on the surface of Earth? Sir, that is g. On the center of Earth, what is that? That is 0. So tell me one thing, my dear NEET and JEE aspirants. Tell me one thing. If we move from the surface of earth to the center of earth, from the surface of earth to the center of earth, what happens to the acceleration due to gravity? Will this acceleration due to gravity decrease or increase? Sir, obviously that will decrease. We have now discussed this in length and breadth. So my dear student, that will decrease linearly. It's like this. It's going to decrease linearly. Okay. So the value of acceleration due to gravity on the surface of earth is equal to g, and on the center of earth it is equal to 0, and the graph is linear. As you move from the surface to center, g decreases, and if we move from center to surface, g increases. So let's stop here. See you in the next lecture. Just all you need to do is that just stay focused. This content is enough for cracking any competitive exam like NEET or CUET or JEE Mains. Okay, all you need to do is that just stay focused and do the question practice. Question practice आप कहाँ से करोगे? Simply from the DPP sheets, and just make as many revisions as you can. See you next time.